when I think about the linear parent function, have any of y'all ever made ice cream?
Yes.
Okay, so you know like when you make ice cream, you make a base first? Okay, well you make a base first, and it's like milk and cream and sugar and like salt, right? And that's like the base. And it's like basic. And I mean basic it's basic. Okay? And it doesn't have a ton of flavor, but it's ice cream. That's the linear parent function. It's just the basic, simplest kind that you can make. The ice cream base is the simplest ice cream you can make. The linear parent function is the most simple linear equation you can write. Now, if I were to like add chocolate sauce or something to my ice cream base, then I have chocolate ice cream. That'd be like changing the slope. Or maybe I wanted to add like cookie dough chunks because I like that. That would be like changing the y-intercept, which sounds delicious, but here we are. So the parent function is the most basic, simplest equation we can write. So now every function family has a parent function. So we're in the linear family, so we're doing the linear parent function. When we do quadratics, we'll do the quadratic parent function, and then we'll do the exponential parent function. Okay? But every family has a parent function. So the parent function for the linear family is y equals x. Simple. It's the simplest equation we can write, okay? Now, if we write down all the invisibles around it, so you know how like there's all the invisible stuff? We would say y equals 1x plus 0. Because the slope of the parent function is 1, and the y-intercept is 0. Now, let's write that down, because that's kind of important for us to know. Right over here, we're going to say m equals 1, b equals 0. If the y-intercept is 0, what is that? What kind of linear function does that make this? Oh, that's right, sir. One person always has the answer. I should put you on mute. Proportional. It makes it proportional, right? Because it goes to the origin. So it's proportional. All right? All right, now, if I were to write that in function notation, do you guys remember when we write in function notation, remember what we substitute f of x for? What is f of x the same as? Who said it? Somebody said a letter. Maybe you were just asking me a question. Y. It's y. F of x is the same thing as y. So I could say f of x equals x is how I would write the parent function in function notation. That's it.
Do we
Okay.
have to write that x equals 1?
Yeah, I would. That's kind of important. But we kind of wrote it over here. But I mean, it's important that you know that. Okay. Huh? I know. It makes it so complicated. I don't know why they have to go and make things so complicated. Anybody get me? Nobody gets me. Okay. Somebody gets me. Okay, somebody on the internet is going to understand what just happened. All right, so here's another thing that is interesting about the parent function. Whatever x is, y is the same. Now, it looks like it says whatever x is, just the same, but it means y is the same. Sorry about that. I don't know why I let everything bleed together like that. Okay, so whatever x is, y is the same. Okay, so that means what if x is negative 2? What's y going to be? Negative 2. Okay, what if x is 0? Y is going to be 0. What if x is the square root of 17? Y is going to be the square root of 17. What if x is negative 4/7? Y is also negative 4/7. And what if x is pi? Oh, pi is delicious. Y is also going to be pi, which is equally delicious. Okay? So, whatever x is, y is the same. So if I were to graph some points, well, I could definitely put a point on 0, 0 because the parent function is proportional. What if x was 3? Then y is 3, so I could plot a point at 3, 3. What if x was 7? Y would be 7, so I could plot a point at 7, 7. What if x was negative 4? I could plot a point at negative 4, negative 4. And what if x was, I'm not going to do any fractions because I'm not here for that, huh? I cannot slow down a little bit. What if x was negative 9, negative 9? Oh, never mind. I don't want to talk about it. But if x is negative 9, then y would be negative 9. So I've got a point there. Now, I'm going to connect those points up. When you guys are done frantically writing down what I just wrote, you guys also connect the points. It doesn't matter which points you use. As long as the x and the y are the same. Yeah. So I'm going to. I'm sorry. Somebody needed an eraser. I'll get you one in a second. Okay. So I wouldn't. Okay. So here. So you are not in athletics. But I should have known that because this is seventh period. Okay, so why did I connect this line? But why is it continuous? Because what? Because of the arrows? But why did I get to put arrows? I just did that. What was the phrase? Can I blank half a blank? Well, what's the verb here? There's no verb. And I don't even know what x is. Can I nothing half of an x? I mean, there's no situation to tell me that I can't have that I can't break this into parts. So we always connect. When there's no situation, it's always continuous. So if they don't give me a situation, if they give me an equation and no situation, it's continuous. Okay? All right. Last thing. What would my domain and range be since I put arrows on this? All real numbers, right? Okay, all real numbers. Because I've got arrows going here and here on my x. I've got arrows going in every direction. That means it's all real numbers. Okay. Now, one last thing I want y'all to write down, and again, this isn't super important, but it kind of helps you see it. It bisects. B-I-S-E-C-T, 8th graders. It bisects, which means cuts in half, quadrant 1 and quadrant 3. So what that means is it kind of it creates an axis of symmetry. So you remember with symmetry, like if I have two things, I can fold them in half and they match up perfectly. It kind of, this line here, if I folded this in half, these two axes would fold right over perfectly exactly on each other and they'd be a perfect match. Okay? All right, so that's the parent function. That's all I have about the parent function.